As artificial intelligence systems replace existing algorithms, one common question that comes up is, how is AI different from existing software coding? Or is it just an extension of what already exists? A traditional software code can be viewed as a set of predefined instructions in the form of a decision tree. If input A is given, then output B should emerge. If condition A is met, then action B should be taken. A human software engineer has to anticipate all scenarios and write the code from start to end. This approach has its limitations. It is practically impossible to anticipate all possible scenarios in complex real-world problems. For example, if you are driving on the road, there is an infinite number of unanticipated situations that you could be exposed to. Or take another example. When humans interact with each other or communicate with each other in natural language, there are an infinite number of combinations of words and sentences that can be used. Artificial intelligence, particularly machine learning based systems, are dynamic self-learning systems. They keep getting smarter on their own with usage. The best way to visualize this is to think of a child. A child learns about the world through trial and error. For example, a square peg does not go into a round hole. That's something a child learns while playing. Or this face belongs to that name. That's another something that the child learns as he or she observes the world around them, and so on and so forth. This learning comes from repeated attempts. Some of them are successful, most of them are not. But each successful attempt creates a link between different neurons in our brain. And every time a set of two neurons interact with each other, the connection between them grows stronger. And that helps them transmit messages faster and more accurately. This pattern of neural connections forms our behavior going forward. A self-learning artificial intelligence system behaves just like that. An AI system has a core function that defines the primary purpose the AI system is designed to perform, and it finds its own paths to achieve that goal. It tries to solve the problem through millions of different approaches and analyzes which of those approaches work best. For example, the problem of reaching from point A to point B in a maze could be solved by trying all possible paths and identifying which provided the best outcome. The more advanced form of this problem is self-driving cars. A self-driving AI system analyzes huge amounts of driving data to figure out which actions led to failure, that is an accident or an inordinate delay, and which actions led to success, that is reaching the destination in an optimal amount of time. Similarly, when huge amounts of human language interactions are fed to the large language models, they figure out the relationships between words and sentences. To an AI model, a language word doesn't have any inherent meaning per se. Each word's value lies in how it relates to other words in its vicinity. As they say in the world of natural language processing, a word shall be judged by the company it keeps. Just like in the case of a human child, the more the experiences that the child is exposed to in their childhood, the better is the child's ability to adapt to various life situations going forward. Similarly, in case of AI, the more the data that the AI is trained on, the better is the AI's ability to adapt to various situations in order to achieve its core function goals.